Everybody hear me okay? Why don't we go ahead and get started? First of all, I just want to thank everybody for coming. I know you're all busy. Also, there's a lot of other sessions, so appreciate you joining and having listened to what I have to say here. So I'll start off with a brief introduction. My name is Dan Scali. I lead Mandiant's Industrial Control Systems Security Consulting practice. Mandiant now a FireEye company. I joined Mandiant back in December from GE, where I led the product security program for a variety of GE's hardware and software products in the SCADA and industrial software and hardware space. And so my focus is really on cyber attacks and cyber incidents that could potentially have physical consequences. So I work a lot in the utility space, oil and gas, transportation, chemical, and other industries like that. So before I begin, I really wanted to go through kind of some terminology and definitions, because I've heard a lot of these terms thrown around. I think there's some overlap, but there's also some important differentiation, right? So when I talk about industrial control systems, the key word there is industrial, right? This is the kind of stuff that's actually controlling some sort of engineering process, right, or something like that. And it may or may not be critical, right? This could be something that's controlling the power grid, or it could be milking cows, right? And so I think there's kind of a few different types of things that you can look at there. And then when you talk about critical infrastructure, critical is really the key word, right? So this is something that kind of underpins the structure of a society or national infrastructure. And so I'd pull in things like financial systems, right, to that, and they don't necessarily have to be industrial. And they've got the whole concept of the Internet of Things and kind of the trend towards having connected thermostats and connected vehicles and connected all sorts of stuff, right? And that's something that's sort of developing as well. So I think these are sort of three different concepts, maybe a bit of overlap between them. But my comments are really going to focus on the first two. And the reason for that is because it's out there today, right? We have industrial control systems that are critical, and they're in the field, and there's a security mission right around that stuff that we need to fulfill. And certainly, our job only gets harder right as the connectivity increases as well. All right, so and actually, before I begin on this, just a quick show of hands. How many attended the session with the gentleman from Deloitte? Okay, so maybe about half. So now I'm going to go through a threat landscape overview, as well, for the benefit of those that weren't in that session, and then we'll get into some of the more technical aspects and what approaches you can have in terms of integrating security into an ICS architecture. So looking at the security in the headlines, right, it paints a pretty bleak picture, right? We've got ICS devices that are connected to the internet. There's tons of vulnerabilities in the products, right? And I think that when you read this, one question that comes to my mind, and I think any reasonable person, is why don't we hear about more attacks, right? And we talk a lot about hypothetical scenarios, and so what I wanted to do is really go through the cyber threat landscape in terms of when Mandiant responds, when our customers call us because they've had a breach, what are the things that we see? I want to apply that to the ICS landscape and then mix in some of the more open source things that you can find that are publicly available. And then talk about some strategies for monitoring ICS and talk about what we can do about it. All right, so some examples that I'm going to pull here are from our report, M-Trends. It details basically when we go out to our client base and they've had a security breach, and they call us in to basically figure out what happened, what was taken, what was the impact, and try to get the attackers out of the environment. So we collect statistics and we compile these on an annual basis to be able to kind of give some indication of trends from an incident response perspective. And so this is really an indication of who's calling us. We respond to thousands of security breaches, so I think it's probably a good picture of the industry as a whole, but it's a selective sample size in terms of the clients that we're working for. And so another, I think to kind of scope out what we're talking about here is that we typically respond to targeted types of attacks, right? So these are attackers that are specifically targeting a particular organization. It's a who and not a what. If you kick them out, they'll return. They're very persistent and looking to achieve a specific objective against an organization, whether that's stealing their intellectual property, whether it's doing something for financial gain, or whether it's some sort of nation-state-based kind of disruptive attack. All right. And so who are we talking about? So sampling of some of the threat actors that are mentioned in the Mandiant report, and again, this is just around the types of folks that we go out and work with. We talk about hacktivism and those types of groups. I'd put the Syrian Electronic Army in that threat profile. We talk about threats that are China-based, Iran-based, and Russia-based as well. And so what industries are we seeing targeted? And if you look at this list, and this is from our report from the last 2 years, you see all the types of industries that have and operate ICS, right? Transportation, chemical, you have energy, and we include utilities in that categorization as well. So the attackers are there in those asset owners that are controlling these industrial control systems and critical infrastructure. And then in terms of detecting compromise, we see some really interesting things in the breaches that we respond to. So the first is that about 2/3 of organizations are actually notified from an external entity. So the FBI or local law enforcement internationally, wherever, calls them up and says, hey, we think you have a problem, and here's why. The other third of organizations call us up and say, hey, we think we found something ourselves, and they're in over their head, or they kind of don't know where to go to kind of dig deeper and understand things a little bit more, so they call us for that. And then another interesting statistic is that it takes about, on average, or the median here was 229 days. So these advanced attackers were moving around undetected in their network for the better part of a year. And in the longest case that we saw last year, it was well over 6 years that the attackers were, unbeknownst to the organization, present in their infrastructure. And again, on the enterprise IT side is typically where we're seeing a lot of the activity. And then another trend, another interesting statistic, is around phishing. And so the majority of attacks that we see are still exploiting, if you saw Kevin Mandiant's keynote yesterday, the human factor. And so the majority of the incidents are around phishing, but if you dig a layer deeper into that, about 44% of those are targeted towards IT administrators. So what we see particularly these attackers looking at is trying to compromise credentials that have a lot of access, right, to other parts of the IT infrastructure. I think that you can put in a SCADA administrator, right, or something like that would be also a really good target for spearfishing. And they also run this stuff like you would any good email marketing campaign, right? You see a spike in the middle of the week when a lot of people are likely to be at their desk and click on something. All right, so again, why don't we hear about more attacks? And I'm going to give a couple reasons. The first reason I'll give you here, and then the second one as we move through. So I think it's motivation and intent. So we know that these actors are present on the enterprise side of the network, we know that they're moving around and they're there. And we know also that if you can take information, you can delete that information, you can cause integrity problems and different things like that. So what I would say is that there's deterrence. I think it's an interesting space politically in terms of if there were something that could be considered a cyber attack, would there be some sort of kinetic response of that nature, right? So, and also there's not a conflict, right, that would really necessitate an attack against some sort of critical infrastructure or industrial control system. So I don't think it's a problem of capability. I think that looking at the access that the attackers have and the profile around who the attackers are, they could absolutely cause some sort of disruption. I'll walk through some examples of things that are known, that we've seen, and that are also public. But I think it's a question of motivation and intent. So walking through the cyber threat landscape, I just want to apply that specifically to industrial control systems. So we see a significant amount of data theft from energy companies, manufacturing companies, and this is stuff that we mostly attribute to be China-based. But there's a couple interesting cases where this stuff moved into the ICS SCADA realm. So Telvent, which is a vendor, sells some SCADA software, pretty popular in the pipeline space as well as others. And they have this remote monitoring and diagnostics operation as well, where they actually connect in to the asset owners. And there's a lot of vendors, not just Telvent, that do that kind of stuff. And they were actually breached. They had to notify their customers, and that's a public event, right, of the breach that occurred. And so the question there is, what was the impact of that, and also, what was the motivation, right? So with source code, you can build that product, right, which is the typical sort of profile that we see from some of the actors that we, again, believe to be China-based. But also, with that level of access, right now, that third-party connection could potentially be a vector into the asset owner organization. You could use that code to search for vulnerabilities, right? So that piece is not really as clear, but what we do know in terms of what's public there was that those types of actors were attributed as breaching and getting some intellectual property of this SCADA software. All right. So the second thing that goes into data theft and is specific to industrial control systems is the HAVEX malware. And so at FireEye, we did a detailed analysis of the malware, and it's pretty interesting how it works. So in this scenario, essentially what happens is they put a Trojan horse into installers for industrial control systems software for the installer. So you go out, you're an engineer, and the two vendors that were targeted, there were three, but 2 out of the 3, they made VPN solutions specific for the industrial control system space. And so you can kind of speculate, based on how this worked, what was happening with that attack. So with HAVEX, let me talk first about what the malware did, and then what I would speculate was the attack path. So what we saw the malware do is, once this particular module within HAVEX gets activated, it basically scans for OPC servers. So OPC, common protocol used in the oil and gas space as well as the manufacturing space, basically to collect information from embedded devices, PLCs, RTUs, other types of kind of field hardware devices, right? So it scans for OPC servers, other devices that speak OPC. It collects all the information that that OPC server is highlighting or advertising, and then it encrypts that stuff up. We believe to then go exfiltrate through some other functionality in the malware. So it's kind of like 2 parts to this. So there's this industrial control system specific module, and then there's this HAVEX platform that's out there, which is essentially stuff that we've actually seen used in other types of attacks. So with HAVEX, it's not specifically an ICS attack. This particular module was looking for OPC, but the broader attack we've seen used in botnet attacks, different things like that. So kind of an interesting iteration or different vector for this group to take a look at. So anyway, that's an example of basically collecting that information. So back to how the attack may have worked. So if you're an engineer that needs to go and make a logic change to an industrial control system, right? VPN is great, right? Because now from my desk or from wherever I am, I can go ahead, I can log in, and I can make my change remotely. And so what I'd speculate is by putting this malware in the installer for that software, the idea again is that they're targeting that engineer with highly privileged access, betting that that engineer is then going to go VPN onto an air-gapped or otherwise segmented industrial control system network, and then once that's connected, then the malware can do its work. So it's just another example of how the attackers are essentially trying to find ways to get over that air gap or get over the network segmentation that's typically in place on the industrial control system side. All right, so moving out of the data theft area, and certainly with the HAVEX thing, right, it didn't only have to take data, right? We saw it taking data. That's our analysis of the sample that we've analyzed, but it could have done something more destructive. We'll talk about some of these other examples. So there's also hacktivism examples. This is one that if you were in the previous session, you saw, but it gets lost in the shuffle because there's a big brouhaha over a water plant in Illinois that was supposedly hacked. Turned out there was a contractor who was in vacation, in Russia and just happened to log in, and that was kind of misunderstood. But what this guy did was he was like, this is ridiculous, people are downplaying this type of attack. So he went out and he found an internet-connected control system in South Houston, Texas, used a Siemens product with a well-documented default username and password. It's 100, nobody go and hack it, he basically posted these pictures of the water facility online, right? And you can bet that the people who operated this facility did not think that they were internet connected. No one, I haven't met anyone who thinks it's a good idea, right? But it still happens because this is a complicated thing to kind of keep track of all the assets that are in your infrastructure. All right, and so the last thing is network attack. And obviously the example that we have here is Stuxnet. So when you look at attack widely attributed to the US and disrupting the Iranian nuclear enrichment program. And so here's an example, again, of a network attack to disrupt, the physical process, stop equipment from spinning the right way, or different things like that. And an interesting thing to talk about, although it wasn't specifically industrial control systems related, is that I think we can paint a story here around blowback, and we've seen, and this is detailed in M-Trends, an increase in the number of attacks that we attribute to groups that could either be based in Iran or sympathize with Iran. And so with the Aramco and Rasgas attacks, basically wiper malware, deleting everything from multiple PCs, we're seeing those types of threats emerge as well. I think there's a story there as well. Okay, so those are the examples. So back to that original question, well, why don't we hear about more attacks? Well, I think that those are some examples, those are the attacks that we have heard of. But I think that actually, most importantly, besides the whole intent question, is that we're not looking for them, right? So put aside the whole thing about industrial control systems and the vulnerabilities and the connection, right? I'm not aware of asset owners that have an effective strategy for looking and understanding, what's going on the ICS network. We're really, really good at instrumenting the enterprise edge of the network as an industry, and finding out what's going on the outbound side of the network and kind of the stuff that's between the internet and the enterprise network. But there's not a lot of people that are actually turning over the rocks or moving the bed or the couch and finding all the dust bunnies under there, right? That might be actually down on the industrial control systems network. And so I want to make an argument here that this is a key step in addition to preventative measures that you can take in order to understand more about what's going on your industrial control systems network. So what should we do about this in terms of getting more visibility? So as I said, there's the typical approach, right? So this is what we typically see asset owners doing, right? So there's a back to the basics approach, right, around who's responsible for ICS security, having an asset inventory, having different architectural standards, right? I mean, that's all stuff that I think is a given. It goes without saying, right? You should be doing that kind of stuff. Not everybody is, but clear that that's a good idea. We also see some level of log aggregation, but a lot of this stuff is compliance-based, specifically in the utility space. So there's NERC SIP regulations, and so really the idea is, hey, I'm going to look at auditability of different logins, right? Things like that. And the last thing is malware controls, right? Also important, right? I'm not saying anything on this list is something that you should be doing. And looking for malware on the control systems. But I think that it's important to argue pretty forcefully that in addition to this, right, there's a couple challenges, right? So the first thing is that industrial control systems are becoming way more connected, right? So it's behind a firewall and the segmentation approach You know, if that, you know, first of all, I'm not aware of many air gaps or, you know, firewalled off ICS networks that are actually that way, right, and could withstand, you know, reasonable inspection. The second thing is that the technology is moving way faster than our ability to secure it, right, as it gets more and more connected. So if you have an air gap now, it's quickly eroding because there's a lot of data on the industrial control systems network that has a lot of business value, right, that's going to need to go and get connected. The second thing is that vulnerabilities will exist indefinitely. So there's a lot of stuff in the industrial control system space, ISA 99, NERC CIF, right? Name your standard. And it's all very conformance-based, compliance-based. Well, if you meet this standard, right, then that's the solution for security. But we know that vulnerabilities will exist indefinitely, right? This stuff is software. There's always going to be some number of bugs and flaws that are going to be exploited. You know, and that preventative measures are eventually going to fail, right? It's the defender's dilemma. We have to plug every hole and tack our own ass to find one. And so, you know, that leaves me with the conclusion, I'm not trying to be negative, but, you know, that security breaches are inevitable, right? We have to plan for failure. And I would argue that that planning for failure is something that is extremely neglected. So if you're in a world where security breaches are inevitable, the mark of a good organization is not the organization that's preventing attack. It's the organization that understands that they're being attacked, knows exactly when that's happening, and is able to mitigate the impact of that successful attack. And that really, I believe, is a goal that needs to be translated very forcefully down into the industrial control systems mindset on the engineering side. Because we see a lot of standards, you know, but not a lot of you know, looking for bad guys. So, you know, there's challenges, right? Again, with the kind of proactive approach and with kind of taking this detect, respond, contain approach. You know, as I said, it's very structured, lots of standards, right? Because engineering culture is very change averse. If you want to put, you know, a software agent somewhere, I think, yeah, that could be very effective in detecting attack, but it's a very tough conversation with the engineers. Well, how is that going to impact the SCADA system? You know, things like, can I get the vendor, whether it's Siemens or GE or Schneider Electric or whoever, can they approve that that agent isn't going to cause any problems with the SCADA, right? So, you know, any sort of changes to the industrial control systems architecture are difficult. And then when you get down to the embedded device level, you know, that's also pretty challenging. You got a lot of old stuff, doesn't necessarily run on standard protocols, right? Different things like that. You know, the second thing is, what are we even looking for? Right, so in my initial question, I think that by nature these attacks are very low frequency and very high impact. And so the other thing around monitoring is you got to even understand what an ICS attack is or what normal looks like on the ICS network in order to be able to even know that something's went wrong. And the last thing is that ICS technology is often flawed. Right? So we may actually not be looking for malware in an ICS attack, right? So things like login with a default password, right? I mean, that's not something that is really malware based. It's a design flaw in the technology itself. And so how do you find that kind of stuff as well? And so I think this is where the passive monitoring techniques, right, come into play. Really well, right? We're not going to touch anything, we're just going to look, right? And the network typically doesn't lie about what's going on. And this is a very good entry point when talking to the engineering groups who are responsible for keeping a mission critical operation, up and running at 5, 10 nines of availability, right? And they don't want to take an outage, right? They don't want some security software to break something. And those are reasonable concerns. I think we have to do a lot better in terms of redundancy, DR, being able to make updates and changes. But the idea here is that passive monitoring techniques are a great first step to start to get into the ICS space and get some visibility. And so there's the practice of network security monitoring. And the idea here is I'm going to collect all the information possible from the network and from other host devices and I'm just going to collect it, right? And I'm going to be able to answer questions about what's potentially going on my network. And the key here is that we're moving away from the issue of showing compliance or conformance to a particular standard or regulation or showing who logged in. And we're actually trying to find, hey, I know that this looks weird and I ought to investigate it. Or this is a known indicator of compromise, whatever it is, right? So moving away from the simple, well, I'm going to be conformant to this security standard, whatever, and starting to look for bad guys. So how do you do that in ICS? So we take the detect, respond, contain model, right? On the IT side, it's pretty well documented, right? You've got widely used technologies. You've got a lot of standardized types of logging. In terms of response, there's a lot of stuff that's going on. You bring in just the IT team, right? And then containment, you find the compromised machine, you unplug it from the network, you do whatever response that you want to do, probably re-image it and redeploy it. On the ICS side, it's a little different, right? So on the detection side, we don't really know what attacks look like. It's not as easy as just mapping a lot of the existing IT technologies down into the ICS space. And then we're by nature looking for that low frequency, high impact type of event that potentially we've never seen before. And that response is going to bring in your operational technology organization, right? So there's going to be a lot of cross-organizational communication that's going to happen. It's not just an IT problem. In terms of containment, well, do you want to re-image the server that's running, your power plant or your, controlling trains or a water system or whatever that critical application may be, right? So this is where, again, we really have to think about DR and resiliency, not just in terms of break fix, but in terms of compromise. So if something's compromised, how do I fail over to something that's actually clean? So that I can clean out that that primary system or whatever it is, and also survivability, right? If I look across my different assets, which ones are the most important to actually keeping the infrastructure going? Can I live without that substation, to take an energy example? Can I live without one point of visibility while I go and kind of contain and fix some other stuff? So it's a little bit of a different approach. But there's a lot of ways that ICS is identical to IT, right? We're seeing a lot more IP-based communication, not just serial-based stuff. And even if stuff is serial, we've taken terminal servers and pushed that into monitoring devices to take full packet captures of serial-based devices, right? So there's ways to do this stuff. You've got a lot of Windows event logs down on the ICS because it all runs Windows for the most part. There's some Unix stuff as well. A lot of the asset owners, especially at bigger organizations or of course within government, they're going to have some sort of SOC or CERT, someone who's monitoring, and that's a security expert. And so getting that relevant ICS information up to that group could potentially help them make a decision or respond or give some additional context to what's going on. And so I would argue that we actually have the tools today to start looking and understanding if we see an attacker on the enterprise network, which if you go back to the intro, we see all the time. Is that attacker interrogating the ICS network? Is that attacker trying to go down to that other layer? Right now, we lose the trail because we're not looking. So how would you do this? So this is just kind of a simple reference architecture for what most ICS will look like, right? So you've got the enterprise IT side, and your strategy doesn't change there. Whatever you're doing on the enterprise IT side, obviously there's always room for improvement, but that's pretty well known. But then as you start to get a little deeper in here, there's some ICS-specific types of problems. But a couple of things that I think make a lot of sense are, number one, in the DMZ side, you're having that ability for full packet capture and other types of data collection, right? Because now when you see something on the enterprise side, is that, as I said earlier, is that attacker trying to get down into the SCADA? How are they interacting, right? And it should be pretty easy, by the way, to collect that amount of information at the DMZ, because there's not a lot of traffic here, right? We're not talking about thousands of users going out and using the internet. We're talking about a handful of users who need to access the charts and graphs or the historian data or whatever it is that's kind of sitting in that DMZ. And so starting to take a look at that, a lot of third-party connections come into here, right, looking for anomalies in those protocols. And the bottom piece is when you get to the actual, real like SCADA specific kind of stuff, right? And this has to be a little more passive. Again, as I mentioned, there's Windows event logs, there's syslog down there. There's other types of things that might be in a proprietary format that might be a little tricky, but between that log collection and the packet capture at the network layer, I think you can get a pretty strong picture of like what's going on, who's logging into what. So from a forensic perspective, you can figure out what's going on. And again, when you see that attack from the top of this diagram, you can actually follow it down into the ICS, because this is probably the least trusted area. Another interesting thing on the ICS side is that you actually have another edge. So you need to watch for attacks from the bottom of this picture, right? Because some of this stuff is actually out in the field. And so what if somebody just walks into a place with weak physical security out at a remote site somewhere, and they clip a lock or something like that?
Wouldn't that be why you would want a firewall at the end of that section where the PLC controllers are? So in case somebody went in through the back side of the controller, it would defend from it getting in the SCADA system? Yeah,
well, so absolutely you want like some segmentation as well, right? So I think that understanding this traffic, I don't see that often, but that's a great control. And then so I'd say that would be step one, right? Would be segmenting off, but then step two would be understanding what's actually going on there, right? Like who's plugging in, what traffic is coming from there. Because even with something like a firewall, right? Let's say I walk into a place with no physical security. I unplug the RTU or the PLC that's there. I plug my laptop into that same port, right? Now I'm pretty much good to go. And we know that it's pretty well documented that there's some vulnerabilities, right, in these types of protocols, and it would be fairly easy to potentially use that, right, as a vector back up into this part of the architecture as well. So anyway, I can go on and on about kind of the threat modeling aspect of this and where the threats would come from, but that's most of the architectures that I look something like this. Well, others look really flat, but ones that have the basic stuff in place kind of look like this. Those are some of the threats, and those are some of the monitoring points. Again, without having to really install things, right? You're forwarding events, you're looking at packet captures, and so your engineering team shouldn't be as queasy like that than they would with really making actual changes or things like that to some of the software. All right, so another thing is that when you go through, and this is actually, I quoted Richard Baitlick earlier, he's written a few books on network security monitoring, and these are the things that he lists as the challenges. And I think that this is interesting because these are things that really aren't an issue, right, for ICS. So encrypted networks. Well, technology is so insecure by design that there's not a lot of encryption. You've got serial, right, different things like that. So you can still see it. The issue of extreme traffic volume I covered. So something like, well, we can only keep a couple hours worth of traffic because there's so much stuff going on. Well, that really isn't an issue because these are typically fairly low bandwidth, right, types of networks. And then privacy concerns. You're not dealing with a lot of user data. You're not looking at what website someone's going to, right? You're just looking at machines talking to each other. And so, again, another reason why I think the network security monitoring model works really well right down at the ICS space. So we've been doing this, and so I just pulled the most recent example of a client that I'm at. So we pulled about 15 minutes of traffic capture from the firewall that was creating that DMZ between the enterprise and the business network. We immediately found traffic that was going directly from the business network down in the ICS. Their ICS is behind the firewall, right? But you can still connect to it through the firewall, right, down into the SCADA network. We found external DNS requests that we're following up on, right? So why on earth would any of those machines that are either in the DMZ or down, into the industrial control systems layer, why would they try to be connect out to the internet, right? We've already talked about the standards. No one really thinks that's a great idea, and they were strange DNS requests as well. So those are things we're following up on. We found potential multi-home devices where someone said, well, this machine really needs to access business stuff and SCADA stuff, so there's 2 NICs on the device. And they're going from, the business net. So basically you compromise that one device, you're on the SCADA network. And then, lastly, really limited segmentation. So they had, a variety of zones set up and areas within the SCADA. None of that was segmented. So once you're on the SCADA, to your point earlier, right, once you're in there, it was kind of like any, right, to everything. And we were able to find, this kind of stuff with just a simple firewall rule review and looking at the traffic itself. And this really, I think, dispelled a lot of myths or misconceptions that the organization had about how really well segmented they were. Because this is hard, right? It's not, I'm not pointing the finger right, at a particular organization. It's a hard job, but the validation is important to understand where you really stand. Okay. So, in closing here, and I'll be happy to take questions, I really think that it's important to redefine the win. There's a narrative around ICS as being many years behind IT, and I do think that that's the case. But I'd also say that we have an opportunity to not make the same mistakes, and I think that by thinking purely in terms of prevention, that's really an approach that will leave you unprepared, right, in the event of attack, or unprepared in being able to trace those attackers that are on your enterprise network as they attempt to attack the SCADA or as they gain physical access, like in the Stuxnet case, right? So we need to be able to come up with adapting the model of detect, respond, contain down in the ICS space. How do we look for these attacks? What do we do in the event of an attack? And then, what's the strategy, as I said earlier, around being able to fail over from system A to system B to contain the compromise? And these are all things that may be unique to the organization, right? I don't have the answer here in terms of details, but I do know that this is a model that if you haven't thought through it prior to having an incident, it's going to be a lot more challenging to do it in the heat of battle. So with that, I'd be happy to take any questions.
Done any of your investigations in the local area?
What's that?
Have you done any of your investigations in the local area?
So we won't. I can't comment on specifics around.
I know that. I just meant a lot of people. Oh, that happens down in Texas and down in Illinois. It doesn't happen.
Sure. So not personally, but I can't comment on any more specifics.
Okay.
In the wake of the more recent ICS-related attacks, compromises, are we seeing vendors actually kind of looking at it and going, well, if people are going to buy our product, they're going to be worried about what happened to those guys? Are we seeing an actual increase in awareness of security of the vendors?
Yes and no. So I have an interesting perspective because I worked for a vendor and had a great time there for 8 years trying to make control systems more secure, right? And so I think often the vendors of the technology are painted as, these guys that come in, light a cigar with a couple $100 bills and put their feet up on the desk, right, and figure out how they're going to screw their customers. And that is not the case, right? I went to work every day and I just really wanted to make this stuff more secure, right, and help customers. And so there is a vendor awareness, but the game is structured in a way that the vendors have no chance, right? I mean, when you think about just the economics of the situation, you want to ship software fast, right? You want to get it out there, and by nature, right, there's going to be vulnerabilities in that because you can't, there's no technical techniques, right, that are going to say, oh, well, this software is free of vulnerabilities, right? So you push this stuff out, you're motivated to ship software, Customers ask for features, 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 and so you get this situation where basically there's a quality issue, and the vendors are just really struggling to catch up. So they get it. The one piece that I would say though is that in my past experience, right, what would really like make my day was when a customer, would go to like the sales guy or whoever else and like bring up security as an issue, right? Because I, as the security guy internal to that vendor, got a chance to go be the hero, right? And try to drive change. So I think there's like a defeatist kind of, well, the vendor will never listen. Really, really like be forceful in pushing the point, be reasonable, don't attach just like, DHS has a list of vendor procurement guidelines, and they're great, but they're not applicable to every situation, right? So when that gets stapled to the back of an RFP or something like that, I mean, it's like, you look at that, and you're like, gosh, like, this is, so there's awareness, but it's like, what do they really want? So I guess I would say be clear and repeat, what you need and what your security requirements are, and be reasonable, and you'll get there. Does that help?
Yeah. It's at this point, I mean, I understand the defeatist attitude because there's sometimes where the department will purchase this grand system that does everything that they ever hoped for and their copy. And we're like, okay, well, how does it work? How do we get the security spec on this? Like, well, we don't know. The software was written by this guy in Israel.
You guys solve, I think if there's one thing that I saw, which is a reason I've been focusing a lot more on trying to help asset owners, is that asset owners are going to have to solve their problem, right? It's not going to be an agency, it's not going to be your vendor. You're going to have to take control and ownership of ICS security for your organization because you're accountable for it. Is there another question?
I was just going to challenge the assertion that vendors are trying to get their software to market so fast that they can't do it securely. I think that paradigm probably exists more on the enterprise side, but an ICS side, I mean, we don't upgrade our data systems every 2 to 5 years.
Mm-hmm.
Vendors can get it secure in 2 to 5 years. They just choose not to a lot of times. Because we're not forcing their hand. We're not forcing them to. We're not saying, if you don't make it secure, we're going to go buy something else.
I think that there is a lot of room for improvement, certainly in kind of the quality level of some of the ICS technologies and the lack of, design for security and stuff like that. But, I don't even know, and I'm not an expert on static analysis, right, things like that. But I've not seen a piece of software, in any space, besides maybe aviation, when you get it down to like, a certain number of lines where you know exactly what the program is doing. And so some space of the program's execution, there could be some bugs and flaws, and some of those are going to be vulnerabilities. So I guess when I say they could meet specific security requirements that you ask for in that 2 to 5 years, and that's absolutely reasonable. But I think that they're going to deliver a product that's got no flaws in it whatsoever. Not really possible.
Yeah, that's not what I was.
Okay.
I'm talking about basic input validation, like really basic.
Yep. So yeah, ask for it, right? Get that into the, and that's a reasonable requirement, right? That's okay. But I still think, I mean, look, Microsoft's been working on this for 15 years, right? You still see issues in the software.
Yeah, one of the things that's been kind of in the back of my mind is that, the Department of Homeland Security, of course, is interested in our critical infrastructure, and, industrial control systems is a major part of that. One of the things that is kind of been sitting in the back of my mind and I've been wondering about is, do you see from your position that Homeland Security or some other agency may make a move to try and regulate this and declare, classify certain types of systems as being critical infrastructure, and then regulate the security, do you see any movement or any direction in that direction?
Yeah, I mean, absolutely, right? I mean, you've got the NIST cybersecurity framework, which I think is more broad, right, than just industrial control systems, but the idea there is for critical infrastructure. So there certainly is, movement there. I mean, what I tell organizations is you want to be able to, essentially, contribute, right, to where, that stuff's going, right? To be able to, rather than have someone tell you, what to do, it's always better to say, well, here's what we do, and it's working effectively for us, and kind of contribute to how, any upcoming regulations or things like that, happen. Because I think it's inevitable, but I don't think that compliance to regulation, keeps you secure, right? Because the issue is that, and we've seen this with NERC SIP, we see this, we respond to a lot of retail breaches, and all those companies are PCI compliant, which is the payment card standard, right? And so, when you look at that, I'm just waiting for the first utility that's NERC SIP compliant to have an event. And then, just take your analogy, elsewhere. So regulation, it gets this box checking approach where we fear the auditor more than the attacker.
Yeah, I'm just waiting for it to change. The NIST and the DHS suggestions become regulation, and I'm waiting for that the scale to tip at that point. And I don't know that I see it. I agree with you. I think it's inevitable. When's it going to happen? By what I'm watching for.
Do we have time for any more questions, or one more?
As far as like the perimeter and the host, I mean, we deal with that all the time, and we're starting to aim more towards host, base protection or intrusion prevention, because we're looking, that's where it's going to happen from for the most part. People will get through the firewall at some point, but is the industry kind of aiming at those devices at the very end to kind of put some smarts into them, or as far as them understanding with their own system to alert, oh hey, there's some weird activity? It seems like a lot of them are just kind of dumb and are going to do whatever,
So what's an example of the type of stuff that you're thinking about?
Well, say you have something that controls a valve for a nuclear power plant. I mean, it's at some point it's an actuator that says go for it, but the device that controls that, I mean, at the very distant end, does it have its own version of a firewall that says, wait, who are you coming in to talk to me and tell me to turn on?
Typically not, right? You have a lot of fail-safes, right? Which is why kind of some of the apocalyptic scenarios I'm pretty skeptical of. But what I worry most about is, from an engineering perspective and a process automation perspective, what you worry most about is loss of view or loss of control, right? And also, if the integrity issues around what I see on my HMI or whatever view I have of the process doesn't match what's actually going on in reality. And so that's kind of the sort of thing with Stuxnet, where, so what I guess I think there are some fail-safes in place, but what I worry about is basically tricking an operator into making the wrong decision.
It looks good on the screen, but actually it's not so good.
Right.
Yeah, does that make sense?
Yeah.
All right, that's all the time we have, but happy chat afterwards.